Welcome back to another video of the channel. My name is Julio. Thanks for tuning in. Before we get started, like, subscribe, hit the notification button, and let's get down to business. So today we're going to be talking about BFD, also known as bidirectional forwarding detection, and the advantages it provides to your network. Let's get inside the details. BFD, also known as bidirectional forwarding detection, is a detection protocol designed to provide fast forwarding path, failure detection times for all media types, encapsulation topologies, and routing protocols. BFD detects failures in a network by exchanging hello packets between two routing devices. BFD also operates in two modes: asynchronous mode and demand mode. Asynchronous mode, which is the one that Cisco devices support, BFD sends hello packets continuously, and the session is terminated if some are not received. Demand mode, BFD only uses a polling mechanism to send control packets after finding a neighbor. But in this case, we're just going to focus on asynchronous mode. So BFD in a nutshell, it uses hello packets to detect failures and establish neighboring. It can be assigned to routing protocols such as OSPF, BGP, eIGRP, etc. And once you configure the routing protocol with BFD and one link fails, BFD will inform the routing protocol. And the metric that BFD uses is the following: interval. This is how often you will send BFD packets to your neighbor. Min-RX, this is how often you will receive BFD packets from our neighbor. And multiplier, this is the hold down time value. It's similar to OSPF dead interval or the hold down timer of other protocols. And almost forgot to mention, BFD is a protocol that can detect link failures, as stated before, in milliseconds or microseconds. All right, so let me break it down to you. We're going to configure loopback interfaces on both routers. We're going to also configure BGP as the routing protocol. And we're going to configure BFD, but only on Ethernet 0/0. And this is because this is my primary node. And the other one is going to be left as a backup. And you're going to see once I disable Ethernet 0/0, it's going to take at least 1 to 2 seconds. And the other neighbor is going to come up instantly, and I'm going to be able to forward traffic using that backup node. And as you know, BGP is slow in convergence, and this is due because the keep alives are set to 60 seconds and the hold on timers are set to 180 seconds by default. So BFD, in other words, is going to tell BGP, hey, my primary link went down. Please store in the routing table the secondary link that I have as a backup. And that's exactly what's going to happen. And the beauty of this is that you don't have to go to the BGP instance and modify the keep alives and the hold on timers. So without further ado, let's get inside CML and let's get started with the lab. All right, so we're inside the CML now. We're gonna start configuring on both equipment the loopback interfaces, the point-to-point, and the BGP instance. The Ethernet 0/0 and 0/1 are not gonna be enabled until we finish all the configuration on both sides. I wanted to show you the BFD with the question mark on their Ethernet 0/0. And as you can see, there's an option to enable BFD, but you can see there that by default is enabled. So the only thing you have to do is just configure the parameters. So in this case, regarding BFD configuration parameters, we're gonna use the default, which is gonna be the interval of 50 milliseconds, and the minimum receive 50 milliseconds again, and then we're gonna input the multiplier, and we're gonna put 3 there. And that's gonna be the hold down timers. Alright, so we're down to the last piece of the configuration on the PE side. We're gonna configure the BGP instance. We're gonna configure the loopbacks, which are gonna be advertised via BGP, and we're also gonna configure both neighbors. The primary neighbor is gonna have the fall over BFD command. Alright, so we're gonna go now to the customer equipment. We're gonna configure the same as the PE side. We're gonna configure loopbacks. We're gonna configure the both point-to-point interfaces, and we're also gonna configure the BGP instance. Alright, so now that we've finished the CE configuration, we're gonna go ahead and unshot both point-to-point interfaces. And as you can see, both interfaces are up. Let's go right ahead and jump to the PE router and do the same command to lift the interfaces up. And as you can see, both interfaces on the PE side are up and running, as well as the CE side. And you're gonna see now that the BFD is gonna form a neighbor relationship using the Ethernet 0/0 on both ends. And BGP is also gonna come up. Alright, so let's do a show BFD neighbors, and as you can see I got the neighbor right there. Let's do a show BFD neighbor detail. Alright, as you can see the session state is up and is using echo function with 50 milliseconds interval, which is the parameters that we configured earlier on the interface, Ethernet 0/0. And as you can see on the routing table, I'm receiving both loopbacks from the CE side on the PE side. And let's go right ahead to the CE and let's do the same command, show IP route. And as you can see, we got both loopbacks being advertised via BGP from the PE side on the CE side. Right, so we're gonna do a standard ping to the 10.0.0.1 with a repeat of 10,000. And we're gonna go right ahead and stop the traffic on Ethernet 0/0. As you can see, I only had one packet lost, and then it started to reply with no issues, using that secondary link as a backup. As you can see, I did a show IP BGP, and the next hop that is being used to reach those two loopbacks configured on the PE side are with the secondary link that we have as a backup. So what I'm gonna do now is I'm gonna enable again traffic to flow again using Ethernet 0/0, and you're gonna see the BGP peering come up again using the primary node. So as you can see, after BGP adjacency came up again using the primary link, I did a show IP BGP, and now the next hop to reach those two loopbacks from the CE to the PE side are now being routed through 192.168.1.1. So this is all for today's video. If you like the content, please give it a like, and as always, this is Julio. I'll see you in the next one. Peace out.